June 26, 1944, Hollandia Air Base, Dutch New Guinea. A game of checkers lay half-finished on the table when Lieutenant Colonel Charles MacDonald looked up from the board. Standing in the doorway was a man who'd just introduced himself, but the name hadn't fully registered. MacDonald was focused on his match with Lieutenant Colonel Merrill Smith, the operations officer of the 417th Fighter Group known as Satan's Angels. The visitor repeated his introduction with calm confidence that made MacDonald pause. Charles Lindbergh. The Charles Lindbergh, America's most famous aviator, was standing in a makeshift recreation hut thousands of miles from home, asking permission to discuss P-38 combat operations. Neither man could have known that this brief meeting would soon transform the way long-range fighter missions were flown across the Pacific. Over the next 6 weeks, Lindbergh would teach techniques that extended the combat range of the Lockheed P-38 Lightning by nearly 400 miles, turning what pilots once considered impossible into standard operating procedure. This was more than a story of technical innovation. It was a story of one man challenging military convention, proving that mathematics could outperform instinct and forever changing aerial warfare in the Pacific. The lessons weren't found in textbooks or engineering manuals, but written in the daily experience of combat pilots who learned that everything they had been taught about engine management was incomplete. The impossible was about to become routine, taught by a 42-year-old civilian who had never flown a P-38 until 3 days earlier. Lindbergh's journey to that dusty airfield in New Guinea had begun 17 years earlier over the Atlantic Ocean. On May 20 through 21, 1927, Charles Augustus Lindbergh changed the world by flying solo from New York to Paris, 3,600 miles in 33.5 hours. His aircraft, the Spirit of St. Louis, carried 450 gallons of fuel in tanks so large they blocked his forward view. Navigating by periscope and dead reckoning, he managed his fuel with a precision that bordered on obsession. When he landed at Le Bourget Field, he still had 85 gallons remaining, a feat experts had declared impossible for that engine. That meticulous control over fuel consumption became his trademark. Throughout the 1930s, while conducting survey flights for Pan American Airways across the Pacific and Atlantic, Lindbergh refined his methods, pushing aircraft far beyond their published range limits. He understood that those numbers weren't hard boundaries, only averages. Every engine had a sweet spot, an exact combination of power output, fuel burn, and airspeed where efficiency peaked. Finding it required a deep understanding of the delicate relationship between manifold pressure, propeller RPM, mixture settings, and speed, far beyond what standard training offered. By 1944, Charles Lindbergh was one of the world's foremost experts on long-range flight, but his relationship with the U.S. military was complicated. His outspoken isolationism before the war and his leadership of the America First Committee had made him a political pariah. President Franklin Roosevelt publicly compared him to Confederate sympathizers. And on April 29, 1941, Lindbergh resigned his Air Corps Reserve Commission in protest. After Pearl Harbor, he tried to return to service, but Roosevelt personally blocked him. Lindbergh would never again wear an American military uniform, yet expertise finds a way. Unable to serve as a soldier, he became a civilian consultant, working for major manufacturers. By 1943, he was with United Aircraft Corporation, advising on the Chance Vought F-4 Corsair. He helped fix production problems at Ford's massive Willow Run B-24 plant, flew high-altitude test missions in P-47 Thunderbolts, and helped develop new dive-bombing techniques for the Corsair. His technical insights were invaluable, but what Lindbergh truly wanted was to return to combat. In early 1944, he saw his chance. United Aircraft wanted to study twin-engine fighter operations, and the Lockheed P-38 Lightning was the perfect subject. Lindbergh proposed traveling to the Pacific Theater as a civilian technical representative to observe real combat conditions and perhaps to fly. On April 3rd, he prepared for deployment. In New York, he bought a naval officer's uniform with no insignia at Brooks Brothers and picked up a small New Testament from Brentano's bookstore, noting in his journal, "Since I can only carry one book and a small one at that, this will be my choice. It would not have been 10 years ago, but the more I learn, the less competition it has." He left San Diego on April 24th, officially bound for Marine Corps aviation bases near Guadalcanal. The Navy had approved the trip, but the White House was never informed.
Neither President Roosevelt nor Secretary of the Navy Frank Knox had any idea that Charles Lindbergh was heading into a combat zone. What began as a quiet technical assignment quickly turned into something very different when Marine Corps aviators invited Lindbergh to fly as an observer on real combat missions. On May 21, 1944, Lindbergh joined Marine Fighting Squadron 222 for a low-level strafing run against Japanese positions near Rabaul. Officially, he was there to observe, but Lindbergh flew with his guns armed, engaging targets whenever he had the chance. It didn't take long for the Marines to see that this was no desk-bound consultant. He immediately began solving problems that had plagued frontline pilots for months. Working with F-4U Corsair crews, Lindbergh showed them how to safely take off with bomb loads nearly twice the aircraft's rated capacity. His precise calculations of power settings, takeoff speeds, and weight distribution cut accident rates and boosted the squadron's striking power overnight. Word spread fast. The legendary Charles Lindbergh was flying combat missions as a civilian and making a difference. By mid-June, Lindbergh's attention had turned to the Lockheed P-38 Lightning. United Aircraft had a genuine interest in twin-engine fighter performance, but Lindbergh also knew that one particular unit, the 475th Fighter Group, nicknamed Satan's Angels, had earned a fierce reputation as the best P-38 outfit in the Pacific. If he wanted to understand the Lightning, that was where he needed to be. On June 15, 1944, Lindbergh caught a ride to Finschhafen, New Guinea. He checked in with 5th Air Force Headquarters at Nadzab and lunched with Colonel Marion C. Cooper, the same Cooper who had co-directed King Kong before the war. A few days later, he dined with General Ennis Whitehead, commander of Allied Air Forces in New Guinea, outlining his plan to observe P-38 operations firsthand. The authorization was informal. No orders, no paperwork. But in the fluid command structure of the Pacific Theater, personal reputation often carried more weight than official channels. On June 20, 1944, Lindbergh strapped into a P-38 for the first time, flying a 1-hour, 20-minute checkout with the 35th Squadron of the 8th Fighter Group. The twin-boomed fighter handled beautifully. 6 days later, on June 26, 1944, he arrived at Hollandia and walked straight into Lieutenant Colonel Charles MacDonald's tent, interrupting a checkers game. MacDonald, just 29 and already a 10-kill ace, commanded the 475th Fighter Group. His squadrons, the 431st, 432nd, and 433rd, flew the latest P-38J models with upgraded cooling systems and extra fuel tanks, giving them the longest range of any Allied fighter in the Pacific. But even these advanced Lightnings had limits. Their range was good, but not good enough. On long missions, pilots often returned with dangerously low fuel, sometimes forced to ditch when storms or headwinds stretched their range beyond safe limits. Several planes had been lost that way. At first, MacDonald barely looked up from his game, politely dismissing the visitor. But when Lindbergh mentioned that he'd been sent by General George C. Kenney's 3rd Air Task Force to discuss P-38 combat performance, MacDonald's attitude shifted immediately. After a brief conversation, he invited Lindbergh to join the next morning's mission. The famous aviator accepted.
Instead of returning to headquarters, Lindbergh stayed overnight in the squadron's tent camp to avoid transportation hassles. By evening, the entire base was buzzing. Charles Lindbergh was flying with Satan's angels. Reactions were mixed. Lieutenant John Perdue of the 433rd was thrilled to meet a living legend. Others were skeptical. A few wondered whether a 42-year-old civilian could handle modern air combat. Major Thomas McGuire, already a 15-victory ace and soon to become the second highest-scoring American fighter pilot of the war, was especially curious. "Let's see what the old man can do," he remarked. On June 27, 1944, Lindbergh strapped in to a P-38 for his first combat mission in a P-38. Rain poured down at dawn, delaying takeoff until mid-morning. At 10:30 a.m., the flight finally rolled down the runway. McDonald led 4 aircraft toward Jeffman Island and Smart Airfield, familiar targets for the group. Lindbergh flew as Blue 3, tucked neatly on McGuire's wing. Lieutenant Colonel Merrill Smith, an 8-victory ace, piloted the 4th plane. Watching from the cockpit, McDonald noted how effortlessly Lindbergh maintained perfect formation, remarkable for someone who had first flown the P-38 less than a week earlier. Their target was an enemy barge in Kaibobo Bay. The lightnings roared in low through bursts of anti-aircraft fire. Lindbergh pressed in tight, his cannon and machine guns shredding the target below. Moments later, it was over, the barge destroyed, all 4 aircraft home safe. But what the ground crews discovered after landing would prove far more important than anything that happened over the target that day. When the ground crew inspected Lindbergh's P-38 after several missions, they began to notice a strange pattern. His aircraft always came back with far more fuel than anyone else's, even when they'd all flown the exact same route. After a 6.5-hour reconnaissance mission on July 1, 1944, along the western shore of Gilving Bay, Lindbergh landed with more than 200 gallons still in his tanks. Other pilots from the same flight limped home on fumes. 2 days later, on July 3rd, the group escorted 16 B-25 bombers in a strike on Jeffman Island. After the attack, the P-38s went hunting for enemy barges. Within an hour, 2 pilots had to turn back, low on fuel. Lindbergh, meanwhile, kept flying, his gauges still showing plenty of reserve. Lieutenant Colonel McDonald couldn't ignore it. 2 days later, he called a meeting. The 475th's pilots gathered in their rough little recreation hut, a palm-thatched roof, dirt floor, a ping-pong table, and a few worn-out playing cards scattered across a crate. Under harsh electric lights, McDonald introduced Lindbergh formally and asked him to explain how, on identical missions, he was landing with so much fuel left. What Lindbergh revealed that night would completely change how the P-38 Lightning was flown across the Pacific. Standing before a room of skeptical young combat pilots, Lindbergh began to explain the cruise control techniques he had developed through experience. Standard procedure for P-38 pilots was to cruise at 2200 to 2400 RPM, with the fuel mixture set to auto-rich. That setting gave good power and reliability, but it also burned fuel at a staggering rate. Lindbergh explained that this safe method was actually wasteful. By lowering the engine speed from 2200 to just 1600 RPM, setting the mixture to auto-lean, and slightly increasing manifold pressure to maintain power, a pilot could dramatically reduce fuel consumption without sacrificing cruise speed. He recommended a specific combination: 1600 RPM, 30 inches of manifold pressure, mixture on auto-lean, and an indicated airspeed around 185 miles per hour. Those numbers, he said, cut fuel burn down to about 70 gallons an hour, nearly 2.6 miles per gallon. The savings were massive. According to Lindbergh's calculations, these settings could extend the P-38's range by roughly 400 miles, allowing 9-hour missions. When he finished, the room went silent. For men who already considered 7-hour missions to be an endurance test, the idea of sitting in a cramped cockpit for 9 was almost unthinkable. The P-38 was no luxury ride. Pilots sat on their parachutes with a life raft jammed underneath, wearing heavy survival gear in tropical heat. The thought of pushing that to 9 hours drew uneasy glances around the room. But the real shock came from Lindbergh's engine settings. Every pilot in that room had been taught that running at low RPM and high manifold pressure, what mechanics called over square, was dangerous. They'd been told that doing so would cause detonation, overheat the cylinders, and blow the engines apart. To them, this civilian was suggesting heresy. Some shook their heads. One or two even muttered that Lindbergh was going to get someone killed. But MacDonald noticed something everyone else couldn't ignore. Lindbergh's P-38 had flown multiple missions that way without a single mechanical problem. His results spoke louder than theory. MacDonald decided it was worth testing. Over the next week, pilots began cautiously experimenting with the new settings. The first test flights were short, just long enough to return quickly if anything went wrong. At first, the engine sounded strange, a deeper, slower rumble. But the gauges told a different story. Temperatures stayed normal. Oil pressure was steady. Cylinder heads actually ran cooler than before. Confidence grew fast. Pilots started using Lindbergh's technique on longer missions, and the results were impossible to ignore. Fuel economy improved dramatically. Missions that had once forced an immediate return to base could now include extended patrols. The P-38's combat radius, which had been around 570 miles, jumped to 700, then 750. Suddenly, they could reach targets that had previously been out of range, fight over them for 15 minutes, and still have enough fuel to get home with an hour to spare. The change was revolutionary. Skepticism vanished. Mission after mission proved the method worked. Lindbergh became a regular presence with the 475th, flying alongside combat pilots and leading sorties himself. His radio call sign was simple: Mr. Lindbergh. He wasn't just showing what to do, he explained why it worked. Airplane engines are about efficiency, not brute force. Power comes from pressure, from burning fuel inside cylinders to push pistons. The more fuel you burn per second, the faster it runs out. High RPM settings waste energy by spinning the engine faster than needed. By lowering RPM and raising manifold pressure, you're getting the same amount of power out of fewer combustion cycles, squeezing more work from every drop of fuel. It was simple physics, backed by math and proven in combat. And it changed the way American pilots flew for the rest of the war. The auto-lean setting that Lindbergh taught provided another leap in efficiency. It gave the engines just enough fuel for complete combustion, no more, no less, eliminating the excess used in the standard auto-rich mode, which was meant to keep engines cooler at high power. The key insight was that Lindbergh's cruise settings, though technically over square by ratio, weren't truly high power. 30 inches of manifold pressure was a moderate setting, far below the 60 inches used for takeoff or emergency combat power. The lower RPMs actually reduced mechanical stress on the engine's moving parts. In short, the method wasn't dangerous, it was just unconventional, a smarter way to fly. Lindbergh's confidence came from experience. His 1927 Atlantic crossing had taught him that aircraft specifications were only starting points, not hard limits. A decade of survey flying for Pan American Airways across oceans had given him thousands of hours to experiment with mixture, power, and airspeed, learning exactly how to coax maximum range from an engine. The P-38, with its twin engines, gave him the perfect platform to push those lessons even further. If one engine failed during experimentation, the other could still bring the pilot home. That redundancy gave him the courage and the margin of safety to test what others wouldn't dare. And there was another factor in his favor: logistics. By mid-1944, Allison was shipping spare V-1710 engines and parts to the Pacific in abundance. Replacing a damaged power plant wasn't a crisis anymore. Ground crews could swap one out in hours. The operational payoff, on the other hand, was enormous. A modest risk of extra wear was a small price for hundreds of extra miles of range. As it turned out, the gamble paid off completely. Not a single P-38 engine failed because of Lindbergh's cruise settings. By late July, his methods had spread far beyond the 475th Fighter Group. Word traveled fast through the 5th Air Force. Pilots swapped notes, mechanics compared fuel logs, and other squadrons started requesting briefings. Soon, Lindbergh was holding informal seminars for pilots from across the theater, explaining, diagramming, and reassuring them that their engines were safe. Adoption wasn't instant, but it was steady, and everywhere it spread, fuel range improved. And then came the day that sealed Lindbergh's legend in the Pacific. On July 28, 1944, he joined the 433rd Squadron on a bomber escort to the Seram area. Flying as Blue 3 in a 4-ship formation over El Paputif Bay, Lindbergh and his fellow pilots encountered a pair of Japanese Mitsubishi K-51 Sonya light bombers, reconnaissance aircraft returning from a search mission. They belonged to the 73rd Independent Flying Chutai, led by Captain Saburo Shimada, with Sergeant Yokogi as his wingman. The Sonyas were hopelessly outclassed. Slower, lightly armed, and less maneuverable, they stood little chance against the high-speed P-38s. Yet Shimada was no rookie. He was a seasoned commander, determined not to die easily. By the time McDonald's flight arrived, another American unit, the 9th Fighter Squadron, was already engaged. Lieutenant Wade Lewis hit Yokogi's plane with cannon fire, setting its wing ablaze. As it began to spiral downward, Lieutenant J.C. Hoslip finished the kill with a burst that sent the Sonya plunging into the sea. That left Shimada alone. For half an hour, the Japanese captain fought a desperate, twisting battle, throwing his aircraft into violent turns that left vapor streaming off the wings. The slower Sonya could turn tighter than the faster P-38s, forcing the Americans to overshoot time after time. Captain Danforth Miller briefly lined up a shot, only to see Shimada roll away in a hard left turn that sent his tracers wide. Then, unexpectedly, Shimada changed tactics. Instead of continuing to evade, he turned straight toward an oncoming aircraft, Lindbergh's. The two planes raced head-on at nearly 500 miles per hour. For Lindbergh, who had flown oceans, tested fighters, and logged thousands of hours in the sky, but never faced an enemy trying to kill him, time seemed to stop. Shimada stayed on course, either attempting a ramming attack or hoping to exchange fire in a final defiant pass. Instinct took over. Lindbergh steadied his aim, centered the enemy's radial engine in his gun sight, and squeezed the trigger. The nose of his P-38 erupted with fire. One 20mm cannon and 4 50-caliber machine guns hammering in unison for 6 full seconds. Tracers streaked through the air, smashing into the Japanese bomber's nose. The propeller slowed. Smoke gushed from the engine, yet Shimada didn't break off. At the very last instant, Lindbergh yanked back on the stick. His Lightning roared over the crippled plane with just feet to spare. Below, Shimada's aircraft plunged into a steep dive, trailing black smoke. Other P-38s fired as it fell, but the Sonya never recovered. It slammed into the ocean in a burst of white spray. Foam spread across the water, then slowly faded back into the waves. Captain Saburo Shimada and his observer were gone.
Back at Hollandia, the question of who deserved credit for the Sonya kill came up almost immediately. Several pilots had hit the Japanese aircraft, McDonald, Miller, and Lindbergh among them, but everyone agreed that Lindbergh's head-on burst had done the real damage. His concentrated fire had shredded the engine, slowing the propeller and sending the plane into its fatal dive. Unofficially, the pilots of the 475th considered it Lindbergh's first and only kill. Officially, it was never recorded. Lindbergh was a civilian, and even his presence on combat missions skirted every rule in the book. Listing him with an aerial victory might have drawn the wrong kind of attention, and ended his time in the field altogether. Just 3 days later, fate reminded him how dangerous that choice could have been. On August 1, 1944, Lindbergh joined a fighter sweep over the Palau Islands. Somewhere over the ocean, they ran into a group of Japanese Zeros. In the swirling dogfight that followed, Lindbergh found himself caught in a turning battle with an enemy pilot who nearly shot him down. The Zero was tight on his tail, cannons flashing. Lindbergh might not have made it if not for MacDonald's calm voice over the radio. "Brake right, brake right." Lindbergh snapped the Lightning into a hard turn just as MacDonald dove in to engage the Zero himself. The maneuver saved Lindbergh's life, but it was too close for comfort. That near-death encounter convinced 5th Air Force Headquarters that it was time to pull the famous aviator out of harm's way. He had done what he came to do. The techniques worked, the results spoke for themselves, and it was time to bring him home before luck ran out. By then, Lindbergh had flown roughly 50 combat missions across the Pacific, about half of them in P-38s with the 475th. He had shot down an enemy aircraft, survived a deadly dogfight, and earned the respect of the men he flew beside. On August 12, 1944, Charles Lindbergh left Hollandia. The pilots of Satan's Angels gathered on the airstrip to see him off. Their respect was genuine. He hadn't just taught them how to squeeze more miles out of their fuel, he had fought alongside them, endured the same dangers, and proved himself where fame and rank meant nothing. The effects of his work were already rippling far beyond the 475th. By October 1944, P-38 squadrons across the Pacific were flying with some variation of Lindbergh's cruise control settings. The exact numbers differed from one unit to another, but the principle was universal. Lower RPM, higher manifold pressure, leaner mixture, all combining to stretch the Lightning's range dramatically. The impact was profound. Targets once thought unreachable were suddenly within range. Japanese bases that had operated safely beyond Allied fighter coverage now found P-38s overhead, fully armed and still with fuel to spare. Bomber formations that had once flown without escort could now count on protection all the way to the target and back. The results were game-changing. P-38s from Dutch New Guinea soon flew missions nearly 950 miles out, engaging the enemy for 15 minutes, then returning home with fuel in reserve. Just months earlier, such operations would have been unthinkable. But the transformation wasn't just about range, it was about time. Every extra mile shaved weeks off the Allied timetable. Campaigns that had once required months of staging could now move in weeks. The faster tempo directly supported MacArthur's island-hopping advance. During the liberation of Leyte in October 1944, P-38s from New Guinea and Morotai provided fighter cover across distances that had previously been impossible. The difference between arriving over the battlefield with empty tanks and arriving with a full hour of fuel often meant the difference between victory and disaster. The technique also saved lives. Pilots who once landed on fumes now had a safety margin. Those who took damage in combat had a better chance of making it home. Sudden detours around storms no longer doomed an entire flight. Not everyone accepted the change easily. Some commanders worried about engine reliability. Others distrusted any method that came from a civilian rather than a military manual. Maintenance officers fretted over possible wear on engines. But numbers don't lie. The evidence was overwhelming. Units using Lindbergh's techniques suffered no increase in engine failures, yet their fuel economy soared. Mission logs recorded operations that had once been beyond reach. By the end of 1944, Lindbergh's once controversial method was no longer an experiment. It was official doctrine. The U.S. Army Air Forces quietly adopted his cruise control techniques into the standard P-38 operating procedures, the culmination of a field experiment that had begun with one civilian, one fighter group, and one idea too good to ignore.
The U.S. Army Air Forces soon made it official. Updated cruise control charts for the P-38 Lightning were issued across the Pacific, reflecting the Lindbergh settings. Pilot training manuals were revised to include proper lean-of-peak mixture operation, a direct result of what one civilian had proven in combat. But the deeper story of Charles Lindbergh's time in the Pacific reveals something far more complex than a technical discovery. Before the war, Lindbergh had been one of America's most admired men and one of its most controversial. His pre-war isolationism and his public admiration for aspects of German aviation technology had earned him accusations of Nazi sympathy. His outspoken opposition to American involvement in World War II had permanently poisoned his relationship with President Franklin Roosevelt. By the time America entered the war, Lindbergh, the man who had once united the world with his transatlantic flight, was viewed in Washington as a political liability. Yet in the Pacific, thousands of miles away from the noise of politics, Lindbergh found something he hadn't had in years: respect. Among the pilots of the Marine Corps and the Army Air Forces, what mattered wasn't speeches or newspaper editorials, it was skill and courage. He proved he had both. Major Richard Bong, America's top ace with 40 confirmed victories, later told reporters, "Lindbergh was as hot a pilot as any of us. He would have been out there knocking down Japs every day if General Kenny had let him." Praise like that, from a man of Bong's stature, meant more than any public rehabilitation ever could. Lindbergh had earned it the only way that counted: in combat. After returning to the United States in August 1944, Lindbergh continued his technical work for the war effort. That October, he attended a joint Army-Navy conference on fighter performance at Naval Air Station Patuxent River, where he flew and evaluated captured Japanese aircraft, providing detailed analyses of their strengths and weaknesses. He continued consulting for United Aircraft and other manufacturers, solving engine and flight efficiency problems reported from the front lines. The numbers behind what he had achieved in the Pacific were remarkable. The P-38J Lightning carried about 410 gallons of internal fuel, 2 90-gallon main tanks, 2 60-gallon reserves, and 2 55-gallon leading-edge tanks, with provisions for additional external drop tanks that pushed capacity to over 1,000 gallons. At standard cruise settings, 2,200 RPM and auto-rich mixture, fuel consumption was far higher than anyone realized. Lindbergh's optimized method cut that down to around 70 gallons per hour total, increasing combat radius from roughly 570 miles to about 750, a 31% improvement. On maximum range missions, with drop tanks and his cruise settings combined, pilots could fly up to 9 hours and cover more than 1,000 miles. In the vast expanse of the Pacific, that difference transformed operations. The island-hopping campaign that carried General MacArthur's forces toward the Philippines depended on air superiority at every stage. Fighter range dictated which islands had to be taken for airfields and which could be bypassed. By extending that range, Lindbergh's techniques gave commanders the freedom to plan bolder, faster moves. Islands that once required costly invasions could now be skipped because fighters could reach targets from farther away. Some later writers mistakenly credited Lindbergh with the long-range techniques used in the 1943 mission that shot down Admiral Isoroku Yamamoto, the architect of Pearl Harbor, over Bougainville. In truth, Lindbergh had no involvement. That mission pushed the limits of the P-38's range, but he didn't arrive in the Pacific until a year later. His contribution was turning what had been an extraordinary one-off into routine, reliable practice. The human side of the story is just as striking. Lindbergh was 42 years old, twice the age of many of the fighter pilots he flew beside. The P-38's cockpit was cramped, its controls heavy, its flights long and exhausting. He endured the same heat, the same danger, and the same hours of numbing vibration as the 20-year-olds who called him Mr. Lindbergh. He never asked for special treatment. He lived in the same tents, flew the same missions, and took the same risks. That willingness to prove his ideas in the air, not just in theory, was the key to his credibility. If he'd stayed behind at headquarters and lectured about fuel efficiency, the fighter jocks would have dismissed him as another ground-bound engineer. But Lindbergh climbed into the cockpit, flew the missions, and came home with the evidence in his fuel gauges. That earned him something rare in the military world: trust. And his example carried a deeper lesson. Lindbergh's success showed that technical expertise from outside the traditional chain of command could change the course of combat operations. Modern warfare, he proved, wasn't just about courage or tactics. It was about engineering, mathematics, and the mastery of complex machines. In that sense, the story of Charles Lindbergh in the Pacific wasn't only about extending the range of the P-38. It was about extending the very idea of what a pilot and a patriot could be.
Lindbergh proved something the military had long resisted admitting: that civilians with specialized knowledge could make real, measurable contributions to combat effectiveness if given the chance. His success changed attitudes across the U.S. Army Air Forces. Commanders began listening more carefully to the technical representatives from aircraft manufacturers, engine builders, and research labs. The collaboration between engineers and pilots deepened, accelerating wartime innovation across every front. The P-38 Lightning itself also deserves its share of credit. Its twin engines gave pilots a margin of safety that made Lindbergh's bold fuel-saving experiments possible. The Allison V-1710 engines, often criticized for their quirks, responded beautifully to his careful mixture management. The Lightning's multiple fuel tanks and complex transfer system allowed pilots to fine-tune balance and consumption, while its steady handling made it ideal for long, precise cruise flight. By late 1944, the P-38 was slowly being replaced in Europe by the P-51 Mustang, which offered superior high-altitude performance and longer range for the same fuel load. But in the vast Pacific, the Lightning remained indispensable. Twin engines meant safety over endless ocean. Its heavy nose-mounted guns tore through enemy aircraft and ground targets alike. And with Lindbergh's techniques, its range was unmatched. The record speaks for itself. The 475th Fighter Group, Satan's Angels, flew P-38s exclusively, scoring 551 aerial victories and becoming the top Lightning unit of the war. Major Thomas McGuire, America's second highest-scoring ace with 38 confirmed kills, flew with the 475th. The aircraft's balance of range, firepower, and reliability made it the dominant weapon of the Pacific skies, and Lindbergh's methods only sharpened its edge. Missions reached farther, fought longer, and returned safer. The full impact of that innovation, multiplied across thousands of sorties and hundreds of thousands of flight hours, is impossible to quantify, but it was very real. Yet Lindbergh's story also exposes the uneasy relationship between individual expertise and institutional rigidity. His pre-war politics had made him an outcast. President Roosevelt's personal hostility ensured he could never again wear a uniform. And yet, the military needed exactly the kind of knowledge only Lindbergh possessed. The compromise, unofficial civilian status with quiet authorization to fly combat, bent the rules beyond recognition. By today's standards, it would have been unthinkable. But in wartime, pragmatism often wins out over protocol. And in this case, it paid off. The pilots who flew with Lindbergh in 1944 never forgot him. Decades later, when interviewed by historians, veterans of the 475th spoke with respect and admiration. Colonel Warren Lewis of the 432nd Squadron could still recite Lindbergh's exact fuel-saving settings from memory long after the war. The numbers varied slightly between squadrons, but the principle never changed, and neither did the results. Charles Augustus Lindbergh died on August 26, 1974. He had secretly left Columbia Presbyterian Medical Center in New York just 9 days earlier, choosing to spend his final week at his secluded home in Kipahulu, Maui. After his death, he was buried within hours in a simple handmade wooden coffin built by local ranch hands, dressed in their work clothes. The grave at Palapala Ho'omau Church overlooks the Pacific Ocean he had crossed nearly half a century before. Only 15 people attended. The marker is a plain concrete slab engraved with a single verse from Psalm 139. "If I take the wings of the morning and dwell in the uttermost parts of the sea."
When his wartime journals were published in 1970, they revealed in his own words what official histories had overlooked: his months of flying combat in the Pacific, his time with the 475th, and his quiet redemption through purpose and precision. The legacy of that service reaches far beyond a few extra miles of range. Lindbergh demonstrated enduring principles: that technical expertise matters in war, that civilian specialists can make a difference if trusted to contribute, that institutions must evolve when evidence proves a better way, and that personal example persuades more than theory ever could. Above all, he showed that progress is always possible, even in systems thought to be perfected. In the final analysis, Lindbergh's Pacific story stands at the crossroads of knowledge and necessity. The Pacific theater demanded impossible range for its fighters. Conventional wisdom said it couldn't be done. But Lindbergh's lifetime obsession with efficiency gave him both the understanding and the courage to prove otherwise. He applied that knowledge under fire alongside men half his age, risking his life to turn mathematics into survival. And he did it not as a celebrity demanding attention, but as an equal, another pilot trying to bring everyone home. The story of German officers stunned by America's industrial might was one of psychological revelation, realizing that material power could crush ideology. Lindbergh's story was one of technical revelation, that mastery of detail could transform the battlefield. Both remind us that victory often comes not only from force, but from understanding. The German prisoners went home convinced that democracy could outproduce tyranny. The American pilots who flew with Lindbergh went home with a different lesson: that knowledge, shared and tested, can make the impossible merely difficult, and that every limit is only the beginning of discovery. The P-38 Lightning flew on until the war's end, its twin-boom silhouette etched forever against Pacific sunsets, and those who flew it in 1944 and after remembered not just the plane, but the civilian who had shown them that limits were only numbers, and that understanding could turn those numbers into freedom.
That was Charles Lindbergh's true legacy in the Pacific. Not the number of missions he flew, nor the enemies he faced, but the knowledge he shared and the techniques he left behind. He had come to the war as an observer and left as a teacher. He had arrived as a world-famous celebrity and departed as a respected comrade. Through nothing more than deep understanding and the courage to challenge convention, he transformed the capabilities of one of America's most important aircraft. The pilots of Satan's angels knew exactly what he had given them. They flew farther, fought longer, and returned home safer because of what one civilian had taught them. A man who understood fuel efficiency better than anyone else in the Pacific. That knowledge, tested in combat and eventually adopted across the theater, stands as one of the most successful technical innovations of the entire Pacific Air War. And it didn't come from a laboratory, a factory, or a research bureau. It came from one man's mastery of an art he had perfected 17 years earlier over the Atlantic Ocean. The same skill that had carried him across 3,600 miles of ocean in 1927 now carried hundreds of young fighter pilots across the vast reaches of the Pacific in 1944. The principle never changed. Know your machine completely. Manage every drop of fuel precisely, and never accept that the limits printed in a manual are the limits of what's possible. For 6 weeks in the summer of 1944, Charles Lindbergh lived that principle, and he passed it on to some of the finest fighter pilots in the Pacific. Those pilots, in turn, shared it with others, spreading a quiet revolution across the skies, a lesson in knowledge, courage, and precision that changed the way America fought the air war.